Now we went over rate laws, but now we want to figure out a way of being able to classify these reactions, as we encounter them, and you do that by something called a reaction order, which basically your reaction order is going to be represented by whatever your exponent is of a particular concentration within the rate law. If by some chance the order is 0, that concentration or that substance won't appear in the rate law because of the fact that if you have an exponent of 0, it just equals to 1. So it's not going to be in your rate expression. And sometimes, within a problem, it's going to ask for the overall order of a reaction. That's just going to be the total of all the exponents for, again, just the reactants. We're not dealing with products in this case. So let's just figure out the reaction order for each of the reactants in this particular equation, and then after that figure out the overall order of this equation as well. Now again, reaction order is just a way of classifying these reactions so that in future problems, if you notice words like first order or second order, you'll be able to at least know what it is that they're talking about. Now when you're looking for the order of a reactant, you can't necessarily look at your equation, and the reason for this is, going back to what I was talking about with the rate laws, the exponents or the reaction orders need to be determined experimentally, and so you can't always go by the equation that they give you because it might not be the same result you would get after you do the experiment. So what you need to look at is actually the rate law. So in this case I gave you the rate law of the following. Now you want to figure out the reaction order of each of the reactants. So in this case NO has a 2 for an exponent, so NO is going to be a second order reaction. For H2 doesn't have an exponent, so that means it's 1, so it would be a first order reaction. And then if we were talking about overall order, it's going to be a third order reaction. Now sometimes though, as you'll see in this particular case, even though you have a rate law, sometimes it's not going to represent each of the reactants that you have within your equation. So even though I said that you wouldn't use your equation to figure out your order, you do have to make sure that you compare the rate law with that equation though, to be able to see, if by some chance you have a reaction order of 0 for something. So for instance, in this case you have a rate law of rate equals K NO2. So the NO is easy to determine. It's just going to be a second order because you have a 2 for the exponent. Now though, if you look at your equation, you'll notice that CO is also a reactant in this case. But CO doesn't appear in your rate law, which means that it had a 0 order. Because of the fact that if you raise anything to the 0 power, it's just basically 1, so you wouldn't see it within your rate expression. So then overall, if you deal with this overall, it's just going to be a second order reaction.